In the last episode, Morgan learned about how the player tracking data is ingested and stored. But all of that data is meaningless if you aren't able to process it, analyze it, and most importantly, derive meaningful insights from it. So how does the Next Gen Stats team do this? Well, let's find out. Now, to start things off, can you explain what led Next Gen Stats to explore machine learning for stats creation?
When we first started out, we were all very excited with the idea of being able to, in real time, capture player tracking data. Know where players are on the field every 10th of a second, how fast they're running. So that was the inaugural stages. Once we got to year 3 and 4, the thing with data is that once you start having more data, you could be like, well, what can we do with this?
We started to realize that those easy stats to calculate from raw tracking data started to get more difficult the more detailed and nuanced they got.
Pure logic alone not only can get very messy, but also it's just not going to properly capture the interactions between players. And that's where I think machine learning does a really good job with tracking data.
Now, how do you decide when you want to use machine learning versus just writing rules to come up with these stats?
Can we do like an example to make it maybe?
Sure.
I think the way expected rush yard model came to be, we started with the question of how do we better describe how well a rusher is performing on a play. And so we could come up with these different features that are involved in the play, how far the rusher was to the nearest defender, yards after contact. And there comes a point where you're like at 5, 6 features where it gets pretty complex for a human to be like, well, that's really important, so let's give it a weight of 5 versus 1. And I think that's when we try to use machine learning. Like, here are all the features that we think is important. And the model is good at finding relationships between the features to make the outcome more accurate.
Training a machine learning model means teaching a computer to recognize patterns by feeding it large amounts of data. In NFL Next Gen Stats, this data includes thousands of plays with precise information like player positions, speed, and direction. That data is fed into a machine learning algorithm. The model starts learning the relationship between the inputs and the outcome. At first, the model makes inaccurate predictions. Each time it gets something wrong, it calculates the error and adjusts its internal parameters, like weights and biases, to minimize those errors. This cycle repeats many, many times until the model learns to make accurate predictions on both training and validation data. By the end of the training process, the model can take new, unseen data and make fast, accurate predictions based on everything it learned. So we talked a little bit about how you're doing this. Could you tell me what tools you're using to make this happen?
Definitely. I think SageMaker is very incorporated in all of our processes. In the initial stage of POC, the proof of concept, it's super easy to just open up the SageMaker notebook, have the environment set up, have the right compute resources to be able to just try things and run quick experiments. And because you're kind of in that SageMaker ecosystem, it's really easy to move on to the next step, which is doing that processing job.
So how do you structure a SageMaker training job for one of these models?
So you launch a training job and say, here's my local script, run this in a GPU environment so that I could train it on a deep neural network. Everything kind of happens behind the scene. I'm not aware of it, but it kind of just works. And at the end of the day, you have the logs, you have the output that gets saved to another S3 bucket, and it's kind of all there nicely so that you could easily retrain, track experiments just by going to that training job instance.
Getting started with machine learning can feel overwhelming, but you're not alone and you don't need to start from scratch. That's where Amazon's SageMaker Jumpstart comes in. It offers pre-built models and solution templates for common ML use cases. Jumpstart enables one-click deployment and easy fine-tuning, helping teams move from idea to insight faster. While Jumpstart provides a strong foundation, organizations like the NFL go even further, combining pre-built tools with custom SageMaker pipelines, real-time inference endpoints, and collaborating with ML experts from the AWS professional services team. Now, are you using SageMaker's built-in algorithms, or are you mostly basing this off of your kind of custom-built frameworks like PyTorch or TensorFlow?
We're using PyTorch. We don't use any of the existing ones from SageMaker. But that being said, a lot of our deep neural networks, a lot of those architectures were created by the ProServe team. So we're never trying to build something from scratch.
What we have learned through our engagements with the AWS ProServe team is their ability to mine that extra 15% so we can go from 80% accuracy to 95% plus.
How do you know when your model is good enough to ship?
Well, first we have the general metrics, precision, recall, accuracy, and there's a certain threshold that we want to meet.
Generally, we want to reduce the amount of false positives and false negatives. And the other one is we want to usually try and be close to the population that we're trying to estimate. So if we have labels for pressure, we want to make sure that our model is not all of a sudden saying that there's twice as many pressures as the ground truth labels.
At the end of the day, our analysts are looking at the output and aggregating it on a player level, on a season level, and then that helps them determine whether this passes their domain knowledge. That's why I say that in our realm of machine learning, there's a little bit of art to it and the science where you kind of need that human, and we trust them because they are the domain expertise to make a determination that this is good or bad.
Join us in the next episode as we take a look at one specific stat, completion probability.